In this question, we are given that Steven swims back and forth along a straight path in a 50-meter long pool for 90 seconds. And his velocity is modeled by this function here, which is a function of time, t. And t is measured in seconds, and v of t is measured in meters per second. And question A is find all times t in the interval from 0 to 90 seconds at which Steven changes direction. And so let's sketch the function v of t. We will use it later on also for other questions. We'll find it useful. So v of t is looking like almost like a sine function because sine is oscillating here. And we'll find this point 0, and then we'll find this point here. This is basically our question here. Why? Because we need to find the point at which velocity changes us from positive to negative or from negative to positive. So we need to find such t at which v of t is equal to 0. And so let's find all those points. And this means that 2 times 38, 2.38 times e to the negative 0.02 t times sine of pi over 56 t is equal to 0. And we can cancel out 2.38 because it's never 0. We can cancel out the exponent because it's always positive. And so really what we need to find is when sine of pi over 56t is equal to 0. And sine is equal to 0 when pi over 56, when the argument times t is equal to k pi, where k is some integer. So let's solve for t here. We get, canceling pi and multiplying by 56, we get that t is equal to 56 times k. And so first, k is equal to 0, so time is equal to 0, but that's not a point where when Steven changes direction because that's when the swimming starts. But then we can plug in k equals 1 and get t equals 56 seconds. And then k equals 2 and get t equals 56 times 2, 112 seconds. But 112 is already greater than the upper limit, which is 90 seconds. So the only answer is t equals 56 seconds. And we see that for all times in this interval at which Steven changes direction, time equals 56 seconds is the answer. Let's move on to part B of this question. In this part of the question, we need to find Steven's acceleration at time t equals 60 seconds. So we need to find a of 60. And acceleration is just a derivative of velocity with respect to time. So it's a derivative of velocity with respect to time. And so then we need to find, use our calculators to find this value. And this will be the derivative with respect to time of the velocity at t equals 60. So let's pull out our calculators and calculate this value. Let's evaluate this derivative at time equals 60. So let's go into math, derivative with respect to time. In my case, it's x, doesn't matter. 2.38 times e to the power negative 0.2 times x times sine of pi divided by 56 times x, and we have to evaluate at x equals 60. Enter. So the answer is negative 0.036. Negative 0.036. And so we just calculated that Stephen's acceleration at time t equals 60 seconds is negative 0.036, and this is meters per second squared, or meters per second. And the second portion, continuing portion of this question is Stephen speeding up or slowing down at time t equals 60 seconds? And it might seem that he is slowing down because the acceleration is negative. But what really we need to look at also, we need to look at the sign of his velocity at that v at the time when time is 60. We need to determine whether it's positive or negative. And recall from the first part, from part A, that when t was between 56 and between 0 and 56 seconds, velocity v of t was positive. And then between 56 and 90 seconds, the velocity was negative, as followed from the graph. And we actually found that at point 56, it changes direction from positive to negative. So v of 60 actually has also negative sign. So this means that Stephen is speeding up at time t equals 60 seconds. So Stephen is speeding up. And so this is the reason for our answer is that both v at 60 and acceleration at 60 seconds are negative. Let's move on to part C. In this part of the question, we need to find the distance between Stephen's position at time t equals 20 seconds and his position at time equals 80 seconds. And so let's again draw that chart for the velocities that we had in part A, and just sketch it approximately. So this is goes like this. This point is 56, this point is 0, so 20 is somewhere here, and then 80 is somewhere here. And so what we are being asked is to find the distance between these 2 points. And we can see that in this case, the distance, Stephen moves in the positive direction. But then in this segment, starting at time equals 56 seconds, he actually moves in the negative direction. So what we need to do to find the distance is to calculate the integral from 20 to 80 of velocity, v of t dt. And so let's pull out our calculators and do that. Let's calculate this integral. That integral from 20 to 80 seconds for the velocity, which is 2.38 times e to the negative 0.02 x sine of pi over 56 times x close parentheses dx. And so the answer is 23.384 meters, rounding up. 23.384 meters. And so we just calculated that this integral is equal to 23.384 meters. And so the answer should be that the distance between Steven's position at time t equals 20 seconds and his position at time t equals 80 seconds is equal to 23.384 meters. Let's move on to part D. In this question, we need to find the total distance Steven swims over the entire time interval from 0 to 90 seconds. And for that, let's again sketch the graph of the velocity. And this is about how it looks like. This point is 56, this point is 0. There is somewhere 0.19. And so what we do for the distance, we need to calculate this area here. And it will be positive if we take the integral. And then we need to calculate the positive part of this area here. But it will be negative if we just take the integral for velocity. What we need to do instead, we need to do the integral of the absolute value of velocity. So what we need to do is we need to do the integral from 0 to 90 of the absolute value of the v of t dt. And in that case, we basically will get both this part here as positive and this area here as positive. Both of them will be positive. So let's pull out our calculators and calculate this area or the total distance. So let's calculate this integral, and that is mathematics, definite integral from 0 to 90 of the absolute value of the velocity, and velocity is 2.38 times e to the negative 0.2 times x times sine of pi over 56 times x dx. And the calculator is thinking. And the answer is 62.164 meters. And so the distance, total distance that Steven swims is 62.164 meters. And so as we just calculated, this total distance is equal to 62 62.164 meters. And so the complete answer will be the total distance that Steven swims over this time interval is 62.164 meters. So this completes question 2, all 4 parts. Thank you, and I will see you in the next video.